Hi guys! In this video, we're going to solve optimization problem. This is gonna be a box problem where we try to maximize the volume of a box. So suppose we get a rectangular sheet of cardboard measured 16 cm by 6 cm. Equal square are cut out of each corner and the sides are torn up to form an open rectangular box. What is the maximum volume of the box? The first thing to do is to make a little picture just to make sure you understand hopefully on what's going on here. So, we get a rectangular box. And we're going to cut out little squares from this piece of rectangular box. And the idea is we're going to fold this remaining flap up, this flap up, this flap up, and this flap up. And then you have a little box with an open top. So one thing I know is that our length is measured by 16 cm and our width is measured by 6 cm. And one thing I don't know in this is I don't know how big the corners, how big the squares should be to make this box with a maximum volume. So yeah, I don't know what they are. I'm just going to pretend that they are just little corners of size x by x. If you think about it, well, you know, the volume of a box is just going to be its length times width times height. If you fold these flap ups, this is our base. This is our base or the side of our rectangular box, which means this letter x value is going to become our height of the box. Think about the length as being, you know, this side of the length of it, where originally it would have been 16 cm long, but we're chopping, you know, the top off. Well, we're subtracting x units right here, and then we're also subtracting x units right here. So the length, we could say it really equals to 16 minus 2x. If you think about this, maybe as being the width, well, really the same thing, since we're tearing away squares, since this length x and this length x, we subtract the width would also be 6 minus 2x. Our length is 16 minus 2x. So first, we're going to simplify our length, width, and height. So our length is 16 minus 2x. So our length is 16 minus 2x. And our width is 6 minus 2x. 6 minus 2x. Since our height is still missing, so we put this x. So after we simplified our formula, we get the values of length and the width, which is these are the values of length and width. So after that, we need it to FOIL to get our functions. First, 16 times positive 6 is equal to 96, and 16 times negative 2x is equals to negative 32x. And then negative 2x times 6 is negative 12x. And lastly, negative 2x times negative 2x, since they are like sign, then our sign is positive. So positive 4x squared. So we still have x. So we have still to multiply all of this by x. So if you think about it, the x getting distributed, well, we would get this. We would get 96x minus 44x squared plus 4x cubed. Alright. So I'm starting to feel pretty good. I've got my function. So the next we're going to do is to derive it. So it becomes our 96, it becomes our is 96, and our negative 44 x squared is, it becomes negative 88 x, and our positive 4x cubed is becomes positive 12x squared. Our function is still not arranged, so we will arrange it in order their exponent. After we get our functions, we also need to find our critical values. And in order to find our critical values, we use quadratic formula. Using quadratic formula, it will guide us to know our critical values. So yeah, let's get started. So the formula of quadratic formula is x is equal to negative b plus minus square root of b squared minus 4ac all over 2a. So this side is positive and this side is negative. 88 plus 56 is equals to 144, and 144 is divided by 24. The answer is 6. This is one of our critical values. So the negative sign is 88 minus 56 is equals to 32. 32 divided by 24 is, the answer is 1.3. So now we get our critical values, 6 and 1.3. After we get our critical values, we also need to find our maximum volume of our rectangular box. In order to find our maximum volume of our rectangular box, we need to use our functions. So our function is v of x equals 4x cubed minus 44x squared plus 96x. So let's simplify it. So since our x is positive 6, so positive 6 cubed minus 44 6 squared plus 96 times 6. So what is the cube of 6? Then we proceed to x is equals to 1.3. So yeah, let's use the function 4x cubed minus 44x squared plus 96x. So let's simplify it. 4, so our x is 1.3. Cube minus 44, 1 times 1.3 squared plus 96 times 1.3. So what is the cube root of 1.3? So the answer of cube. So the cube of 1.3, we're going to times 4. So the answer is 8.79. And then this one, the square root of 1.3, we're going to times 44. And the answer is 74.36. And then the last is 96 times 1.3. The answer is positive 124.8. To calculate this all, we get the answer 59.23. So this is our answer. So after we solve it all, we can now identify our maximum value of our rectangular box. So our maximum value of rectangular box is the value of 1.3, which is we get the answer of 59.23. The positive 59.23. This is our maximum value. Thank you for watching.